We tend to imagine the universe as silent and frozen, a vast black ocean scattered with remote points of light. But when we peer deeper, we uncover something entirely different. From Saturn's radiant rings to the ghostly glimmer of faraway nebulae, space reveals itself as a gallery of impossible beauty, each scene stranger and more mesmerizing than the last. For countless centuries, humanity has traced the stars and spun legends from their mysteries. The ancient Egyptians marked the rising of Sirius to measure their seasons, while early astrologers sought divine order in the sky's silent geometry as far back as 3,000 years before our time. Now, even with the universe mapped and technology in our hands, our fascination has never faded. That's because space is overflowing with wonders that defy imagination. From glowing nebulae that astonish us with their color and scale, to the hidden enigmas of dark matter and dark energy that still baffle the sharpest minds on Earth. In this film, we'll explore some of the most extraordinary and mysterious marvels scattered through the cosmos. We'll drift into the crimson mists of the Orion Nebula, a cradle of stars where fire and shadow intertwine. We'll gaze upon the pillars of creation, colossal towers of dust and light, revered for their celestial beauty. And finally, we'll reach Hoag's object, a perfect ring suspended in darkness, too flawless to dismiss, too enigmatic to define. Each place tells a different story. Each reveals a new kind of awe. These are the jewels of the universe, and this is only the beginning. Now our voyage through the stars begins. Hidden high in the northern sky, within the constellation of Pegasus, lies something the human eye can never truly see. No vivid colors, no spiraling arms, no misty glow of gas or dust. At first glance, it seems almost like an error. Just 5 faint points of light, 4 bright and 1 dim, placed in a near-perfect cross. But behind those tiny sparks is one of the universe's most extraordinary stories. And it begins not with the dots themselves, but with the vast emptiness between them. Around 400 million light-years from Earth drifts a galaxy. Ordinary, hazy, a blur of stars and dust adrift in darkness. Yet its position is special. It sits directly before something far, far beyond. Behind it, nearly 8 billion light-years away, blazes a quasar, one of the brightest, most violent objects in all of existence. A quasar forms when the monstrous black hole at a galaxy's heart consumes matter so fiercely that the chaos around it glows with the power of a trillion suns. The light from that distant quasar has been racing through the cosmos for billions of years, more than half the age of the universe, until it reached a barrier it could not cross, only curve around. The galaxy in front, simply by existing, bent the space around it. Its mass warped space-time itself, shaping the invisible fabric of reality into a cosmic lens. The quasar's light, instead of traveling straight, followed those bends and valleys in space. By the time it reached us, it had split into 4 separate streams. 4 points of light surrounding the central galaxy, each one a slightly different path from the same source. This is the Einstein Cross. It is no illusion, no trick of reflection or overlapping galaxies. It is pure light, ancient and untamed, reshaped by gravity into a perfect cross that feels too precise to be natural. In 1915, Albert Einstein predicted this very thing. His general theory of relativity revealed that mass curves space, and that light, always following the shortest possible path, would bend with it. A few years later, astronomers proved it during a solar eclipse, when starlight was seen deflecting slightly around the sun. But that was only a small hint. Einstein himself doubted we would ever witness a full gravitational lens, where light would twist so sharply that it would duplicate and ring around its deflector. Then, in 1979, astronomers at Kitt Peak Observatory in Arizona saw something strange, a quasar that appeared in 4 places at once. Skepticism followed. Could it really be the same object seen 4 times? By 1985, improved observations confirmed it. The background quasar, the lensing galaxy in front, and Earth's position were aligned with cosmic precision, producing a glowing cross in the night sky. It became one of the most striking visual proofs of Einstein's ideas. Not numbers or equations, but an image, gravity captured in motion, shaping the path of light itself. What's even more remarkable is what those 4 points truly represent. They look like 4 separate galaxies, yet they are not. They are 4 echoes of the same quasar, seen through the warped window of space-time. The light bends around the galaxy's mass, creating 4 unique images of a single source. But the light doesn't arrive all at once. Each path through warped space is a different length, a different journey. Some rays take longer, curving wider around the galaxy's core, while others slip through shorter routes. So each of the 4 points shows us the same event, but at slightly different moments in time. It's like hearing the same voice echoing through 4 distant valleys, each shout arriving a heartbeat later than the last. The Einstein cross lets us watch time itself split, layered and folded in front of our eyes. Even within the lensing galaxy, the story deepens. Its structure is far from smooth, filled with drifting stars, clouds of dust, rivers of gas, and invisible dark matter. As these stars move across the quasar's bent light, they cause tiny, unpredictable flickers. Astronomers call this microlensing. To most of us, those flickers are imperceptible. But to scientists, they are clues. Each small variation helps map how mass is arranged inside the lensing galaxy, how dark matter flows through it, even what the quasar itself looks like up close. In this single, delicate formation, just a handful of faint points in the black, we find a universe of revelations. A quasar from the dawn of time, a galaxy warping space-time into a natural lens, 4 overlapping snapshots of one object separated by time, and gravity itself acting as a cosmic sculptor. Yet beyond all the science, the Einstein cross remains a symbol of quiet wonder. A shape drawn by gravity's invisible hand, proving that even light must bow to the curvature of space. It isn't only what the universe has done that astonishes us, but how precisely it has done it. 4 flawless points of light, arranged in such perfect balance. They seem almost deliberate. A celestial cross, a lens-borne reflection holding 4 shimmering fragments of something 8 billion years away. It's the sort of pattern you might expect to find carved into the walls of an ancient cathedral or painted across stained glass, not suspended in the emptiness of space. Yet there it floats, a whisper of geometry, a silent emblem formed by the laws of physics themselves, revealing a secret symmetry beneath the chaos. It reminds us that even in distortion, there can be grace. The Einstein cross is, in truth, an accident, a cosmic alignment of chance. The quasar, the lensing galaxy, and our distant planet happen to fall into perfect line. Shift the galaxy slightly aside, and the cross would fade into nothing. Nudge the quasar off its axis, and the pattern would dissolve into blur. This delicate perfection exists only because of balance, timing, and the invisible pull of gravity. But perfection in the cosmos is temporary. Over countless millennia, that alignment will drift. The paths of light will warp. The cross will slowly disappear. Yet for this fleeting age it remains, a monument to order born from coincidence, there for us to gaze upon and wonder. Now we turn from illusion to something we can truly see. Ahead lies a galaxy visible even to the humble backyard telescope. A spiral so sharply defined it seems drawn by hand. Our next destination, the Sombrero Galaxy. They say the universe is chaos, explosions, collisions, endless clouds of gas and fire. But every so often, something in that chaos looks deliberate, calm. As if the universe paused for a moment to create something almost perfect. If you point your telescope toward the southern rim of the Virgo constellation, you might find one of those rare places. At first, it's only a dim blur, but as the focus sharpens, it becomes unmistakable. A bright white center wrapped in a dark, razor-thin band, like a silver coin dipped in shadow, or a pearl wrapped in smoke. They call it the Sombrero Galaxy. The name fits exactly. It looks like the wide-brimmed hat it was named after, not through imagination, but through its structure. A glowing central bulge, a razor-edged band of dust cutting across its heart, and a wide, flat disk of starlight stretching far into space. Suspended in the void, it looks almost posed. Officially, it's Messier 104, discovered in 1781 by the French astronomer Pierre Méchain, and later added to Charles Messier's catalogue. But it wasn't until 2003, when the Hubble Space Telescope captured its image, that the galaxy became iconic. Hubble's high-resolution photo revealed something far more intricate than any ground-based telescope had shown before. Fine dust lanes twisting like braided strands, backlit by a blinding core. The result was mesmerizing. The internet took notice, and the sombrero became one of the most downloaded space images of the early 2000s. So what exactly are we seeing? The Sombrero Galaxy sits about 31 million light-years away. The light we see now left it when saber-toothed cats still roamed Earth. Astronomers classify it as an SA-type spiral galaxy, meaning a large central bulge with tightly wound spiral arms. From our perspective, we see it edge on, hiding the spirals and highlighting the ring. That dark band isn't an outline, it's dust. Thick, cold, ancient dust stretching across the galactic disk like a ribbon. And inside that dust, everything moves. Radio telescopes detect molecular gas flowing through it, the raw material of new stars. Deep in those lanes, young suns are quietly forming. Not in violent bursts, but in slow rhythmic pulses. Some regions glow faintly in infrared light, warm from newborn stars still cocooned in their birth clouds. They're invisible light, but infrared observatories like Spitzer and James Webb can see them clearly. That ring of shadow is more than decoration. It's a cradle of light waiting to awaken. At the heart of the sombrero lies a monster, a supermassive black hole, estimated at around 1 billion times the mass of our Sun, among the largest in any nearby galaxy. It doesn't glow or roar, it simply pulls. It anchors the center, its gravity so powerful that surrounding stars orbit it like sparks circling a hidden fire. Beyond the visible ring, the galaxy extends far outward. Surrounding it is a vast halo, a sphere of ancient stars and globular clusters. Over 2,000 have been counted, nearly 10 times more than those orbiting the Milky Way. These clusters are cosmic fossils, dense spheres of stars born billions of years ago. Their abundance hints at something unusual. The sombrero may not be a pure spiral galaxy. It might carry traits of an elliptical one. Some astronomers believe it's a hybrid, a bridge between two great galactic families, balanced perfectly between order and evolution. And that's what makes it hypnotic. Balance. The symmetry feels unnatural, too perfect. The bulge sits in the center, the disk evenly spread, the light smooth and poised. It feels designed, a diagram of how galaxies should look, clean, complete, serene. But the universe doesn't create for beauty's sake. That precision is the result of billions of years of gravitational choreography. Nothing in the sombrero is still. Every glimmering point is a sun, every streak of dust in motion. What we see as stillness is actually harmony, forces locked in dance. That's what gives it beauty. Look long enough and it feels like art more than science, but even art hides its flaws. The sombrero's dust ring isn't perfectly flat. It's slightly warped, bent at the edges, a soft imperfection in its symmetry. A reminder that no beauty is flawless, that even in balance, something always moves out of line. The pearl-like glow at its core isn't a single light, but billions of stars, some ancient, some just born, all shining together, forming a single luminous heart framed by darkness. That darkness isn't just shadow, it's dust blocking the light behind it, a natural silhouette that makes the bright regions stand out. It's the contrast that defines it, light and dark in perfect tension. That's why the sombrero shines so vividly, why it stands out while others fade. The balance of illumination and obscurity makes it unforgettable. You can sense the motion, imagine the structure, but the secrets remain hidden. And that's part of the beauty. Not everything in the universe reveals itself. Not everything should. Even with today's most advanced telescopes, the sombrero still keeps its mysteries. How it formed, why its halo teems with clusters, what truly happens inside that immense black hole. There's always more to uncover, always more veiled behind the dust, but not all galaxies are so composed. Some can't hold their shape. Some are stretched, torn, merged and reborn, locked in an endless struggle of motion and collision. So we leave this stillness behind, the quiet rings and clean lines, and dive headlong into chaos, into a place where 5 galaxies are trapped together, pulling each other apart. Out in the deep silence between galaxies, far beyond the reach of any sun or world, 5 galaxies hang together like dancers caught mid-motion. From a distance they seem serene, luminous arms stretching toward one another, halos blending, trails of light weaving into the dark. It looks peaceful, almost graceful. But the calm is only an illusion, because not all 5 belong to this group. One is merely passing by closer than it seems. The others, they are bound together in a slow, violent embrace. Their gravity pulls and twists them, warping their shapes, stirring vast rivers of gas that glow from the heat of impact. This isn't a quiet meeting. It's a magnificent collision unfolding over time. This is Stephan's Quintet, one of the most striking gatherings in the known universe. Discovered in 1877 by the French astronomer Édouard Stephan at the Marseille Observatory, it became the first compact galaxy group ever recorded. Early telescopes couldn't reveal much, only 5 faint smudges in the dark clustered together. But even then, something felt strange. Their closeness, their light, their placement. Decades later, astronomers discovered the truth. Only 4 of them are truly neighbors in space. The 5th, known as NGC 7320, sits much nearer to Earth, around 40 million light-years away. It just happens to lie along the same line of sight. A cosmic coincidence. So while it appears part of the family, it's really a foreground actor, framed perfectly in the scene, but untouched by the other's turmoil. The remaining 4 galaxies are the real participants, bound in a gravitational drama that has lasted hundreds of millions of years. They collide slowly, not in bursts but in drawn-out gestures. One brushes by, another dives through. Gas is stripped away. Stars are thrown into space. Their luminous arms stretch like torn silk across the void. These are not calm interactions. They are long, unending struggles driven by gravity's hand. Patient, powerful, unstoppable. Through a telescope, the sight is extraordinary. You see them frozen mid-collision, spirals smudged, tendrils of light unraveling into emptiness. Their colors, softened by distance, shimmer faintly, but their motion feels alive. Some seem to fold inward, others stretch apart. The space between them glows not from starlight, but from gas heated to millions of degrees. A cosmic furnace born from impact. You are witnessing shockwaves in real time. One galaxy, NGC 73188b, crashes into the group at nearly 900 kilometers per second, fast enough to cross the United States in less than 5 seconds. As it tears through the intergalactic medium, it creates a wall of compressed particles, a glowing scar visible across light years. This isn't gentle starlight, it's fire on an unimaginable scale. NASA's Chandra X-ray Observatory mapped this chaos as ribbons of heat. The James Webb Space Telescope peered deeper, revealing veins of star formation buried in the dust. Together, their images tell the story of creation through collision, where shattered gas clouds collapse and ignite into newborn stars. Destruction and birth happening side by side. It's not graceful, but it is breathtaking. A living painting of motion, not stillness. Each galaxy plays its role. NGC 73119 hosts a blazing supermassive black hole, a quasar bright enough to pierce the darkness. NGC 7317, small and round, remains more intact, anchoring the scene. The twin spirals NGC 7380A and NGC 7318b spin together, their interaction recent and raw, their luminous trails still fresh. These faint extensions are called tidal tails, immense streams of stars and dust pulled out like threads. Some stretch more than 200,000 light-years, curling and twisting across the void. Within these streams lie clusters of new stars, glowing knots of life born from chaos. Webb's infrared eyes have pierced the dust to reveal these infant suns shining through the haze. Even as the galaxies destroy one another, they also create anew, and in their struggle, we glimpse our own future. In roughly 4 to 5 billion years, the Milky Way will collide with Andromeda. It won't be a crash in sound or flame. Space is too empty for that. But a vast gravitational merger. Stars will pass through one another like ghosts. Some will be flung into the dark between galaxies. Others will spiral inward. Over time, both galaxies will fuse into one immense elliptical shape, formed by chaos, balanced by gravity. Stephan's Quintet is our preview, a mirror tilted forward in time. Eventually, the 4 true members of this group will merge too, forming a single giant elliptical galaxy, far larger than any of them are now. Around it will linger a faint halo, the ghostly remains of stars scattered outward during their long dance. It will look nothing like the tangled web we see today, but its history will remain etched into its form. This transformation will not happen quickly. It will unfold over hundreds of millions of years. A slow, violent ballet of motion and mass. Astronomers believe the final merger will take 1 to 2 billion years, depending on their orbital paths and speeds. So, as the galaxies of Stephan's Quintet twist, collide, and reshape one another. There's a rhythm hidden within their chaos, a strange harmony in destruction. And as we drift onward through the dark, we leave their turmoil behind and turn our gaze toward one of the most iconic and haunting visions ever captured: the pillars of creation. Almost 3 decades ago, in 1995, NASA's Hubble Space Telescope captured an image that would change the way we see the cosmos. Towering shapes of gas and dust rising in the Eagle Nebula, sculpted by light, wind, and time. That photograph became one of the most iconic in all of astronomy. They called it the Pillars of Creation. And from the moment it appeared, it reshaped how we imagined the birth of stars. It spread across classrooms, magazines, and murals, a symbol of cosmic wonder, frozen in light. These colossal structures lie within the Eagle Nebula, a stellar nursery roughly 7,000 light-years away in the constellation Serpens. To put that distance into perspective, 1 light-year is how far light travels in a single year, about 186,000 miles per second, which means the pillars stand nearly 42 trillion miles from us. Every image of them is an echo from the distant past, a glimpse of light that began its journey long before the first cities on Earth were built. When Hubble revealed them to the world, people compared the pillars to castles in the sky, vast towers rising in silence, or to deep-sea coral sculpted from dust. The largest of these pillars stretches nearly 4 light-years tall, roughly the same distance that separates Earth from Alpha Centauri, our nearest neighboring star system. Within them, dense knots of gas and dust slowly collapse under gravity's pull until the pressure ignites nuclear fusion, and a star is born. The process doesn't stop there. As these newborn stars ignite, they carve into the clouds around them with their radiation and fierce stellar winds. Some parts collapse, forming new stars. Others are ripped apart. This endless cycle of birth and destruction makes the Eagle Nebula a living workshop of creation, a place where the universe builds and rebuilds itself in slow motion. The structure was first noted in the early 20th century by astronomer John Charles Duncan. Using the 60-inch telescope at Mount Wilson Observatory, he described them as elephant trunks, vast columns of dust, heavy and curved, being sculpted by starlight. The modern name Pillars of Creation came much later, drawn from a sermon by Charles Spurgeon in 1857. Words meant for faith, repurposed for the stars. The pillars glow because they are surrounded by newborn suns, massive and fierce, whose ultraviolet radiation burns against the gas, illuminating their edges in light. The result is both violent and beautiful, a portrait of contrast, of shadow and fire. It's a cosmic sculpture of birth and decay, of light reaching upward into the dark. Over the years, scientists have revisited the region through different telescopes, each revealing more of its hidden structure. When NASA's Chandra X-ray Observatory studied the pillars, it found something puzzling: fewer young stars than expected. Normally, newborn stars blaze brightly in X-rays, but inside these towers, there were almost none. It led astronomers to wonder, had the pillars already passed their prime? For those unfamiliar, a protostar is the earliest phase of a star's life, a sphere of collapsing gas that hasn't yet ignited nuclear fusion. During this stage, gravity and heat build until, one day, hydrogen begins to burn in the core. Then, the protostar becomes a full-fledged star, joining the cosmic dance that fills the universe with light. In 2022, the James Webb Space Telescope turned its infrared eyes on the pillars of creation, cutting through the dust that once hid their depths. What it found was astonishing. Webb's images revealed newborn stars forming right at the tips of the columns, shining with fierce clarity. The combined vision of Hubble, Chandra, and Webb painted the most complete portrait yet, a detailed map of how stars are born, live, and reshape their environments. But what we see is not the present. The light that left the pillars began its journey thousands of years ago. The structures themselves are in constant motion, reshaped by radiation, carved by the winds of massive stars. Some astronomers believe that a supernova may already have torn through the region long ago, its shockwave erasing parts of what we still see today. Because of the vast distance, those changes won't reach our eyes for millennia. The image we know so well is a memory, a moment that has already passed. And yet, it endures. The pillars of creation remain a breathtaking meeting point between art and science, where human imagination meets the universe's endless creativity. They remind us that space is not empty or silent. It is alive, evolving, and filled with beauty born from chaos. As our telescopes grow sharper, we continue to peel back the layers of this masterpiece, discovering details that have waited billions of years to be seen. After 30 years, Hubble's image still stands as more than a photograph. It is a story still unfolding. The next generation of observatories will reveal more, and with every glimpse, we'll learn again that the universe is full of wonders, each one waiting patiently for us to find it. A nebula is a drifting ocean of gas and dust suspended in the darkness of space, shaped and sculpted by gravity radiation, and the shockwaves left behind by dying stars. These vast clouds come in many forms. Some are planetary nebulae created when stars like our Sun reach the final chapters of their lives, casting off their glowing outer layers. Others are the shattered remains of massive stars torn apart in violent supernova explosions. But not all nebulae mark endings. Some are the first, breath of creation, emission, nebulae. Like the Orion Nebula, are the cradles of stars, the birthplaces where gravity weaves new suns from the ashes of old ones. Though they can span dozens, even hundreds of light years across, these clouds are impossibly thin. Not solid like the clouds that drift through Earth's sky. Even in the densest heart of a nebula, a single cubic centimeter may hold just a handful of atoms compared to the countless molecules that fill every breath of our atmosphere. But when ultraviolet light from newborn stars floods through these fragile regions, the gas ignites, glowing in colors that mark the beginning of creation. The Orion Nebula does not rest quietly. It burns alive with light, a swirling cavern of pink-violet, and gold set ablaze by the energy of young stars within its heart. Temperatures soar into the millions, with the surrounding gas glowing at nearly 10,000 Kelvin hotter than the surface of our Sun. Through a telescope, it doesn't look like a point of light, but like a frozen storm. Ribbons of crimson and silver twisting through shadow, an endless canvas that paints itself in motion. About 1344, light years from Earth, in the sword of the Orion constellation. This immense cloud, known also as Messier 42, stretches nearly 24 light years across. It is one of the few nebulae visible to the naked eye, and a gateway into the process of star formation itself. Part of the vast Orion molecular cloud complex, it is the nearest giant H2 region to our world, and our clearest window into the making of stars. At the core of this glowing storm lies the trapezium cluster, a fierce gathering of young massive stars. Born only a few million years ago, 4 dominant O and B type stars blaze at its center, especially Theta 1, Orionis C, more than 30 times the mass of our Sun, and tens of thousands of times brighter. Their ultraviolet light floods the nebula, stripping electrons from hydrogen atoms. When these electrons reunite with protons, they release light most strongly in the H-alpha spectrum, giving the Orion Nebula its luminous reddish glow. That light does not spread evenly. Radiation hollows out chambers and tunnels, shaping the gas like wind-carving canyons through stone shadows of dark dust, twist between glowing filaments, forming silhouettes and patterns both chaotic and elegant. But those dark regions are far from empty. They are nurseries deep within them. Clouds collapse under their own weight, giving birth to hundreds of stars still hidden in the dust. And within those cocoons spins something even more remarkable. The beginnings of worlds captured, first in detail by Hubble in the 1990s. These small disks of dust and gas orbiting young stars called protoplanetary. Disks, or proplyds, are the seeds of future solar systems, each only about the size of our own, but holding all the raw materials for planets to come. Some already show gaps carved by infant planets sweeping through their orbits. Each one a silent glimpse of what our solar system once was. Billions of years ago in the Orion Nebula, we do not merely witness light, we witness formation itself, creation, frozen mid-sentence. Some regions shine softly, scattering the glow. Others cast long tear-shaped shadows, each one a tiny cradle holding the ingredients for worlds, moons, and perhaps life millions of years in the future. But this nursery is far from peaceful. It is wild, electric, alive with jets of matter called Herbig-Haro objects flung from the poles of forming stars. These beams of gas race through space at hundreds of kilometers per second, colliding with the surrounding material and lighting up in shades of blue, green, and violet under telescopes like Hubble or Webb. They look like something from science fiction, slender spears of radiance piercing the dark. Yet they are real. The raw tantrums of stars still being born. Everywhere you look, the Orion Nebula shifts, reshaped by the very stars. It has created the same radiation that paints it in color, also tears it apart in only a few million years. A blink in cosmic time, the glowing cloud will disperse. The newborn stars will remain, but the veil that sheltered them will fade into the black, its story complete. The Orion Nebula was first recorded in 1610 by the French astronomer Nicolas Claude Fabry de Peiresc, and later described in rich detail by Christian Huygens in 1659, who realized that it was far more than a hazy star. He was gazing at the living breath of the cosmos centuries before anyone knew what that meant. To the naked eye through a backyard telescope, it glows as a ghostly green-white smear. But through long exposure photography or the eyes of space telescopes, it bursts into life, reds from hydrogen, blues from oxygen, and deep lanes of dust threading the scene. It looks alive, a tapestry woven by time itself. The same process happening here once forged our own sun 6 billion years ago, and the tiny disks scattered across this nebula mirror, the beginnings of our own solar system. The Orion Nebula reminds us that creation is not gentle. It is violent, chaotic, and beautiful. It is forged in collisions in gravities, grip in pressure, and light. Here beauty is born from turmoil. Stars claw their way into existence, then shine so fiercely they carve shadows into the clouds that made them, and that light crosses the abyss, so we may see and wonder. That is why the Orion Nebula stands among the most breathtaking sights in the universe, not merely for its color or shape, but for its story, for the motion and fire of creation itself. It is a realm where light is born, sculpted, and set free, one of the rare places where we can watch the act of creation unfold across the cold, dark theater of space. And yet this tale of fire will one day fade, as every star that is born must one day die. And our next journey will lead us from the brilliance of a stellar nursery to the final breath of a dying sun. In the still breath of winter skies, one star glows with a strange and steady warmth. It does not glitter like its neighbors. It smolders like an ember resting at the edge of a fading fire. Look toward Orion's shoulder on a cold December night, and you'll find it hanging low above the horizon, glowing a deep and patient red. That star is Betelgeuse, a soft ember in the heavens, flickering quietly, never fully still. Its light seems to breathe, sometimes swelling, sometimes dimming, yet always there, pulsing faintly through the cold air. There is something haunting in that glow. Unlike the sharp blue brilliance of Rigel, Betelgeuse has a tenderness to its fire, a weary red haze that speaks of age and endings. It is not the fierce blaze of youth, but the slow sigh of a life lived long. You can almost sense it. Exhale, as though the sky itself grows tired and heavy with memory. Betelgeuse is what astronomers call a red supergiant, and that is not poetry. It is a stage of life when a star nears its end. Its hydrogen fuel, long spent it, now burns heavier elements within, fusing helium into carbon and climbing the ladder toward iron inside its heart. Those reactions form layers like the skins of an onion, each shell glowing with a different element, each one closer to collapse. That process swells the star to an impossible size. If Betelgeuse were placed where our sun is, its outer layers would stretch beyond Mars, nearly reaching Jupiter over 1 billion kilometers wide, a size so vast it defies imagination. It is one of the largest stars we can see, and one of the most luminous red supergiants ever known, with a mass roughly 10 to 20 times that of our Sun. But a volume hundreds of millions of times greater because it has expanded so much, its gravity has weakened the outer atmosphere, drifts loosely around it restless and unstable. Whole regions of gas rise and fall like slow tides within a star beneath that fiery skin. Convective cells the size of our solar system churn and roll, bringing hot gas upward, while cooler gas sinks back down. This constant motion stirs the surface until it trembles. With turbulence, immense plumes of gas are hurled into space like solar flares, magnified 1,000-fold. Telescopes have captured these violent outbursts. Hubble observed them in the 1990s, and again decades later, seeing the surface change shape, blistering and dimming across its vast face. The Alma Observatory in Chile has mapped cooler arcs and clouds of gas flowing outward. In uneven waves, vast storms drift across its surface, as if continents of flame were shifting and breaking apart each patch, cooler or hotter than the next. All this roiling motion makes its light unpredictable. Betelgeuse does not shine with constancy, it beats with a slow rhythm of its own. It is what astronomers call a semi-regular variable star. Its brightness rises and falls over cycles roughly 400 days long, though smaller changes ripple across shorter timescales. This variation comes from both the physical pulsing of its outer layers and the changing distribution of hot and cool gas upon its face. Observers have watched its rhythm for centuries. The records stretch back to the 1800s and likely far earlier. But in the closing months of 2019, something extraordinary occurred. Betelgeuse dimmed. Not just a little, but dramatically. Its familiar glow weakened to only a fraction of its usual light. The 11th brightest star in the sky slipped to the 21st by early 2020. It had faded by more than 60%. Across the world, astronomers and stargazers turned their eyes to Orion, wondering if they were about to witness a cosmic death. The great red star's collapse. The headlines called it the Great Dimming. Was this the moment Betelgeuse would go supernova? Would we see a star die in real time? For weeks, observatories from NASA to the European Southern Observatory watched its every flicker. Telescopes large and small followed that fading red ember. Some believed it was the final countdown, but the truth was subtler when the data came in. It told another story. Betelgeuse was not dying yet. It had simply coughed. A massive plume of its outer atmosphere had been thrown into space, cooling and condensing into dust that drifted between us and the star like a curtain drawn across a stage. It wasn't the end, only an outbreath. Still the message lingered. Betelgeuse is fragile, ancient, and nearing its final act. Its name traces back through centuries, from the Arabic Yad al-Jawza, meaning the hand of Orion. The central one, the star, has been known to human eyes for thousands of years, charted by Greek astronomers and studied by Islamic scholars. But only in recent decades have we truly understood what is happening deep inside that faintly trembling red glow. The star is now burning through its final reserves of fuel, fusing heavier and heavier elements within its core, carbon, neon, silicon, until finally iron builds up at its heart. When that happens, fusion will stop. No new energy will be made to hold up the weight above, and the core will collapse inward in less than a second. In that instant, everything changes. The outer layers will crash down, then rebound as a wave of energy races outward, tearing the star apart. This is the birth of a Type II supernova. And when it comes, Betelgeuse will blaze brighter than the full moon, its light visible even in daylight. For weeks across Earth, the familiar red shoulder of Orion will explode into brilliance, becoming a second sun for a brief time before fading to ash. That explosion will not be simple destruction, it will be renewal. The elements hurled outward, iron, nickel, silicon, oxygen, will seed the galaxy, enriching nearby clouds. of gas that in time will form new stars, new planets, perhaps even new life. The death of one giant will become the beginning of many others. This is how the universe recycles itself. What remains afterward depends on the mass of the core, if it is light enough. Betelgeuse will leave behind a neutron star, a dense remnant, no larger than a city, yet heavier than the sun, spinning rapidly and sending out pulses of radiation across the void. If the core is too massive, it will collapse further into a black hole, a point of such gravity that even light cannot escape either way. What endures will be small, dark, and strange compared to the vast swollen star we see today. For now, though, Betelgeuse lives, and there is beauty in that living. Not the radiant youth of stars in birth clouds like the Orion Nebula, but a quieter beauty, the beauty of endurance, of fragility, of age. Its glow is the glow of experience of a flame that knows it will fade, yet burns anyway each shimmer across its surface. In memory of time, it reminds us that even in the universe's cold expanse, warmth can come from endings, not just beginnings. There is grace in the slow unraveling of light and dignity in the exhaustion of stars. And when Betelgeuse finally exhales, its last breath, what follows will not be silence, but transformation. The outer shells will drift into the cosmos, forming a ring of glowing gas that will expand and cool. Over centuries, a cosmic eye slowly opening into space, staring outward toward eternity. That is where we go next, to the Helix Nebula, the silent eye of God watching from the dark. Once you know where to search, it's impossible to overlook. Beneath Aquarius in the southern heavens, a quiet form waits, graceful, spectral, and strange, known to many as the Eye of God. Astronomers call it NGC 7293, the Helix Nebula, resting about 655 light-years from our world. It's among the nearest planetary nebulae ever found, and when you glimpse it through a telescope, it truly feels like it's looking back. The Helix Nebula appears like an eye suspended in space. A pale, icy blue heart surrounded by faint rings of green, gold, and rose. Its hues ripple outward like ripples frozen in time, breath turned to light. Unlike the sweeping spirals of galaxies, this pattern is tighter, almost tender, the slow unraveling of a sun-like star's final act. Billions of years ago, it lived much as our own sun does now, fusing hydrogen into helium, its gravity and pressure in quiet balance. But when that fuel ran dry, gravity won. The core shrank while the outer layers swelled outward, turning the star into a vast red giant, hundreds of times its former size. In time, it grew restless, losing those layers one veil at a time, not in violence, but in pulses spanning tens of thousands of years. At the center now lies what remains, a white dwarf, no larger than Earth, yet weighing more than half the sun's mass. A teaspoon of its matter would crush mountains. It no longer burns, only glows with the ghostly heat of what once was, reaching surface temperatures near 100,000 Kelvin. Given enough ages, it too will fade into a black dwarf, though the universe itself is not yet old enough for such relics to exist. Around that ember drifts a sphere of gas about 2.5 light-years wide. Its glow comes from the ultraviolet radiation pouring out from the white dwarf, energizing the surrounding atoms. When those atoms capture lost electrons, they release color. Oxygen shining green-blue, hydrogen blushing red, nitrogen glowing amber. These colors form the famous eye, a layered spiral of luminous breath. But beauty here is not just color, it's motion and memory. The rings shimmer with irregular edges because the dying star never released its winds evenly. In its final years, it first blew slow breezes at 10 kilometers per second, then faster gales over 100 kilometers per second once the core collapsed and grew fierce again. Those newer winds crashed into the older ones, creating shock fronts, thin shells of gas marking the rhythm of death. Inside those arcs lie the nebula's secrets, cometary knots, dense clumps of gas and dust about the size of our solar system. Each knot glows with a bright head and trails a dim tail pointing away from the white dwarf, sculpted by stellar wind and radiation. They seem to fly, though they barely move, drifting slowly apart. In 1996, Hubble's sharp eye captured thousands of these knots, each one shaped differently, some thick and shielded, others dissolving like mist. These fragments may explain the uneven texture of other nebulae and perhaps influence how new stars and planets one day form from recycled dust. The Helix Nebula is young by cosmic time, only about 10,000 years old, a newborn ghost of light. Eventually, its gas will thin into the interstellar dark, leaving only the white dwarf cooling in silence. For now, we watch its final shimmer, the gentle exhale of a star like our own. German astronomer Carl Ludwig Harding first recorded it in the 1820s. Later observers studied it again as telescopes improved through the 19th century, realizing it was unlike anything else. Its closeness to Earth gives us an intimate view of what awaits our own sun in distant ages. The name planetary nebula misleads. It has nothing to do with planets. Early astronomers simply saw its round, colorful disk and thought it resembled one. What we now know is that these shapes are not worlds in formation, but worlds ending. The last sigh of a sun. That's what makes the Helix Nebula quietly magnificent. Not its brightness or size, but its calm. It's the stillness of completion, the grace of letting go. Billions of years from now, our sun will do the same. Swell, fade, and leave behind a white dwarf surrounded by a fading halo, a painting made of atoms and time. This is how stars end. This is how light retires. And as we drift from this serene eye toward the next mystery, we leave behind creation and death alike, stepping into the places where there is no star at all, only the hollow silence that follows light. There exists a kind of beauty that never glitters or burns. It doesn't shimmer, flare, or scatter color across the heavens. It waits instead, silent, enormous, and still. That is the strange grace of the Boater's void, a silence so deep it feels carved into existence itself, a structure built not from matter, but from the absence of it. It was first uncovered in 1981, when Robert Kirshner and his team at the Harvard-Smithsonian Center for Astrophysics were mapping galaxies through their redshift data, measuring how they drift through space as the universe expands. They weren't looking through telescopes, but building a three-dimensional portrait of the cosmos, tracing where galaxies gather and where they don't. And there, inside that grand pattern, something astonishing appeared. A region more than 300 million light-years wide, almost completely empty. Imagine placing the Milky Way at its center. You'd need to travel roughly 150 million light-years in any direction before finding another crowded region of galaxies. Our own galaxy is just 100,000 light-years across, making the Boater's void thousands of times larger, yet holding almost nothing. A space that size should contain thousands, tens of thousands of galaxies. This one contains fewer than 60. The void isn't a perfect bubble either. It stretches and bends, more like a wound in the cosmic web than a sphere. When mapped in 3D, it opens like a hollow chamber inside the vast filaments of dark matter, gas, and galaxies that frame the skeleton of the universe. For scientists of the early 1980s, this discovery was deeply unsettling. Their models, based on cold dark matter, an unseen ingredient shaping cosmic structure, predicted voids, but not one this huge or so barren. It was as if cartographers charting a forest suddenly found an ocean-sized clearing. To make sense of it, some proposed the void merger hypothesis. Perhaps the Boater's void, formed as smaller pockets of emptiness, expanded and merged together over billions of years, like bubbles in rising dough. As the universe stretched, its expansion driven by dark energy, those smaller voids may have fused into one immense hollow, a patchwork of nothing bound by time itself. Others looked even further back, suggesting that the Boater's void could be a leftover scar from the universe's birth. Instead of forming later, it might trace back to quantum fluctuations, tiny ripples of energy that erupted right after the Big Bang. During the brief moment of cosmic inflation, a fraction of a second after time began, those minute ripples ballooned outward, seeding the pattern of matter and emptiness that would define everything. If so, the Boater's void could be a fossil of that first trembling, a frozen echo of creation itself. Those ancient ripples still glow faintly today in the cosmic microwave background, the faint afterlight of the Big Bang. And if this idea is true, then this vast hollow is not an accident of galaxy evolution, but a direct imprint of the universe's first heartbeat. Most imagine space as simply empty, yet the universe is exquisitely structured. Galaxies thread along filaments, meet at nodes, and circle yawning gaps of darkness. Even the emptiest regions usually contain faint gas, stray dwarfs, and invisible dark matter halos. But the Buddha's void is emptier still. Its scarcity itself bends gravity. Because dense regions pull harder, the galaxies along its edge are tugged away, drifting outward in what astronomers call peculiar velocity. Like water sliding from the lip of a drained well, matter migrates toward denser zones, leaving the void ever more hollow. By tracking these flows, how galaxies shift around the void, scientists refine their understanding of dark matter, dark energy, and the cosmic web. Voids aren't merely gaps, they are the universe's counterbalance, the negative space that shapes all structure. The Buddha's void reminds us that emptiness has weight, that silence has form, and that the unseen is as defining as the light we chase. It shows how even nothingness can sculpt the shape of everything. The name comes from the constellation Boötes, near the bright star Arcturus. Yet the word itself carries a different echo. Like boot, a step, it feels as though the universe pressed its heel into the floor of space, leaving behind a permanent dent, a footprint of absence. And from that silent footprint, we turn to something entirely new. Not enormous, not hollow, but precise. A ring of stars so perfect and symmetrical, it seems almost crafted, as if the cosmos itself took a ruler to the dark. In a universe overflowing with spirals, storms, and scattered clouds of light, Hoag's object stands apart. A single, perfect circle drawn against the dark. It doesn't twist or coil like other galaxies. It sits still, a ring of luminous blue wrapped gently around a golden heart, as if carved by patience itself. Picture a soft sphere of old, amber stars glowing at the center, surrounded by a flawless halo of new, brilliant blue ones, each burning with youth and clarity. No tails trail behind it, no messy arms or nearby neighbors pull at its edges. Just precision. A symmetry so clean it looks impossible, as though the cosmos stopped for a moment and exhaled a single shape into being. This is Hoag's object, catalogued as PGC 54559, one of the most extraordinary galaxies ever found. It was first seen in 1950 by Arthur Hoag, who mistook it at first for a planetary nebula, the dying shell of a lone star. But when further observations revealed its true scale, the discovery became stranger. This wasn't a cloud, it was a galaxy, yet one that refused to fit anywhere on the familiar map of spirals and ellipses. Its golden core resembles an old elliptical galaxy, round, dense, and quiet. But surrounding it is a sharp, detached ring of vivid blue stars, forming an almost perfect circle. That outer ring spans about 120,000 light-years, slightly larger than the Milky Way. The inner sphere stretches 17,000 light-years across, separated by a dark, nearly empty gap tens of thousands of light-years wide, a quiet moat between youth and age. Most ring galaxies show signs of collision, twisted tails, or scattered streams left behind by another intruding system. But Hoag's object shows nothing of the kind. Its form is too pure, too undisturbed. It floats in solitude about 600 million light-years away, in the constellation Serpens, surrounded by emptiness. The ring blazes with young, hot O and B-type stars, each short-lived and intensely bright. Ultraviolet imaging shows new stars still being born along that edge, while the core glows faintly with older, redder light, a relic of a galaxy long past its youth. Spectra reveal almost no gas in that inner sphere, star formation there ended eons ago. That contrast, the calm gold of age against the electric blue of creation, gives Hoag's object its haunting beauty. It is time itself made visible, the old and the young holding perfect distance. But how did it form? One theory speaks of a head-on collision long ago, a smaller galaxy plunging through the heart of another, forcing gas outward in expanding waves that froze into a ring. Such events can create ring galaxies, but usually leave scars, distortions, traces of chaos. Hoag's object has none. It is immaculate. Others suggest slow, internal change, secular evolution, where gravitational instabilities gently move matter outward over billions of years. But that would require a bar structure, which Hoag's object lacks. So perhaps the truth lies in something quieter. The slow accretion of cold gas from intergalactic space, drawn inward over time until it gathered into the glowing ring we see today. Yet even this theory falters before the impossible symmetry, the unbroken, empty gulf between the ring and its golden heart. That empty space, the silent gap, tens of thousands of light years wide, is one of its most mesmerizing features. The ring spins smoothly, held in balance by the gravity of its core and the invisible weight of dark matter that surrounds the system. Spectroscopic data shows the rotation is stable, suggesting it has existed, unbroken, for hundreds of millions of years, perhaps far longer. And then, behind it, if you peer through the hollow center of the ring, you find a surprise. Another, fainter ring galaxy in the background, perfectly aligned. First revealed in Hubble images in the early 2000s, it seems like a reflection, a delicate echo placed just beyond reach, as if the universe, satisfied with its first drawing, painted another within it. Some compare it to a mandala, a symbol of cosmic order. Others call it a celestial eye, a portal, a reminder that even in the chaos of creation, perfection can still emerge. Hoag's object offers no explanation. It only exists, serene, complete, waiting to be understood. Its future is uncertain. The brilliant blue stars will one day fade, the ring may blur, and gravity may slowly pull it inward. But for now, in this fragile moment, it endures. A golden heart surrounded by a ring of light, the calmest circle in the universe. And so we arrive at the point where chaos gives way to symmetry, where the restless galaxies slow into silence and light gathers itself into meaning. We've drifted through cradles of stars where light is forged in violent birth, through the crimson pulse of dying suns, through drifting clouds that seem to stare back like eyes, and finally into the vast quiet that the universe keeps for itself. Each place revealed something different, yet together they whispered the same truth, that beauty in the cosmos is not rare or fragile. It is constant, written into every breath of creation and every trace of decay. What we've seen is not decoration. It is the handwriting of physics, unfolding in slow motion over billions of years. Rings appear because stars follow the pull of momentum. Nebulae shine because light slips free from the husks of collapsing cores. Even the dark voids exist because matter gathers elsewhere, shaping silence through its absence. Every curve, every shimmer, every hollow is a record of movement etched in light. The universe does not repeat itself, yet it remains consistent, not through copies, but through patterns. And within those patterns, beauty emerges, not from intention, but from inevitability. From the faintest grain of dust to the grandest sweep of galaxies, meaning lies in the way things take shape. You only have to look long enough, and the universe will show you that it has been beautiful all along.